All right, this is section 10.3, part 5, and our final video for the section. All right, so we have done several examples now of testing hypotheses for population mean, and we are going to talk more about significance. So just as a reminder, statistical significance was when we had a really small chance of something occurring by chance if the null hypothesis is true. So basically, this is just saying that we have a p-value is small. It's a numerical check without really looking at whether or not there's an actual difference in the values. What we're going to talk about today, when we talk about more significance, is the idea of practical significance. And practical significance needs to be taken into consideration as well. So let's take a look at that. All right, so our book defines practical significance as the idea that while small differences between statistics and parameters stating the null hypothesis are statistically significant, so we test a hypothesis and we actually do reject the null hypothesis, but the actual differences may not be large enough to cause concern or be considered important. So in other words, what we're saying is that results are practically significant when the difference is large enough to be meaningful in real life. And so let's take a look at where we might need to bring practical significance into our decision making when we're dealing with something in statistics. All right, so here's our last example for section 10.3. In 2003, the average age of a mother at the time of her first childbirth was 25.2. So this is years, of course. To determine the average age, if the average age has increased, a random sample of 1,200 mothers is taken and it's found to have a sample mean age of 25.5 years with a standard deviation of 4.8 years. And we want to determine whether the mean age has increased using a significance level of alpha equal 0.05. Let's go ahead and just do the quick check for our three conditions. We do have a random sample. We're told that right there. Let's see. There we go. So we have a random sample. We have a sample size greater than 30 for sure. And then if we check to make sure that 1,200 divided by 0.05, if we're talking about all mothers, I think we can assume that there are more than 24,000 mothers that we could have chosen from. So I think we're safe with condition 3. All right, so I've put our information pulled from the problem here on the left, and let's see if we can make sure we write down the correct null and alternative hypotheses. Of course, our null hypothesis will always use the equal sign, and it will be our statement of no change. So in 2003, I believe, we said that we had a mean age of 25.2. What we're wanting to test is whether or not this has increased. So we know if mean is now greater than 25.2. All right, we're going to use our calculators to test our hypothesis. And to do that, of course, we're going to go to stat, over to test, down to t-test. We do still have statistics, so I can just make sure and put in my new null hypothesis. Whoops. Got to be careful. Make sure and use that down button. Let me get back there. There we go. So now, put in our null hypothesis. Oh, that was our mean. Goodness gracious. There we go. 25.2. And our sample data, so we had a sample mean of 25.5, standard deviation of 4.8, and a sample size of 1,200. We want to know if this has increased, so I need to change my alternative hypothesis to be greater than. And then I'm going to calculate. And here we go. So I'm getting my test statistic. So for the online homework, it'll ask you for that t equals. So I've got my test statistic there. What I want to know is what's my p-value. And so here's my p-value. That's what I'm going to look for to compare with alpha. So p-value versus alpha. So of course I'm comparing to a significance level of 0.05. And I've got a p-value of 0.015. That's definitely less than 0.05. So I would reject the null hypothesis. Now, I'm not going to write the conclusion for this one. It would be the same as all of our other conclusions. What I want us to look at is, yes, there is statistical significance. So this right here, this is, do that in a different color. Whoops. We'll use blue. So, oh, that's not what I meant. There we go. So this right here, our p-value being less than alpha and our decision to reject the null hypothesis, that is statistical significance. And so we have that. But what we want to look at is this right here. How much? Yes, it has increased. It has increased 0.3 of a year. And when we look at that, 0.3 times 12, that's about 4 months. So is that really something that we need to go in and say, oh, or mothers are giving birth to their first child later in life because of 4 months? No. So the practical significance is a big no. There's only 4 months different. And so it's just not a significant enough result for us to suggest or say that women are becoming a first-time mother later in life. Like when I hear someone saying later in life, I feel like that means more from like they were giving birth to their first child at 18 or 19 and now it's 25. That's significant. That's several years different. This is several months, and not even several. This is a few months. So that's our idea of practical significance.